Calculate the total area of the region bounded by the curve y equals 1 minus x squared, the x-axis, and the line x equals -1 and x equals 2. When finding the area, the first step is to draw or sketch the graph of the bounded regions using all the curves and lines given. Remember that the x and the y axis are the help lines only, so we will draw them not too bold, not too dark, lightly, not too dark. This is the help lines only. For the curve y equals 1 minus x squared, if x is 0, then y equals 1. So this curve will go through the point 0, 1. That will be the y-intercept. When x equals 0, y equals 1. If we take y equals 0 and solve for x, then we see that this can factor at 1 minus x times 1 plus x equals 0. So x equals 1 and x equals -1. And if we isolate x squared, don't forget the plus or minus. And so the x-intercepts are when x equals -1, y equals 0. When x equals 1, y is also 0. And so we have to graph the parabola concave down that go through these 3 points. And remember, this is the parabola that concaves down. This is not the bounded region. We only sketch one curve. The x and the y axis, the help lines only. They are not part of the bounded regions, so we have to move on. The x-axis, we then put in the x-axis. This is not part of the bounded region. Even though we see the bounded regions here, but this is not the intended bounded region. We have to keep going here. The line x equals -1 is a vertical line that goes through x equals -1. So this is the line x equals -1. The line x equals 2, which is again the line that goes through x equals 2. And so by looking at this, all of these curves and line given, we see that the bounded regions is between the curve y equals 1 minus x and the x-axis from -1 to 1. Also, it is bounded from x equals 1 to x equals 2 between the curve and the x-axis. So there are two bounded regions. One is above the x-axis and one is below the x-axis. If we compute the integral from -1 to 1, we will see a positive numerical value for the first region. But then if we compute the definite integral from 1 to 2, we will see a negative value. We're looking for the total area, so we will need to take the absolute value of this area below the x-axis. And to do that, we will separate this integral into two. First, we will find the first bounded region, A1 area, and then we'll find the area of the second region, A2, where A1 is the definite integral from -1 to 1 of the curve 1 minus x squared dx. A2 will be the definite integral from 1 to 2 of 1 minus x squared dx. But remember that this second integral will be negative, and we would have to take the absolute value. To evaluate each of these definite integrals, we first find an antiderivative. An antiderivative of 1 is x, and an antiderivative of x squared is x cubed over 3, where we use the power rule. We then plug in -1 and 1 and evaluate them. Plugged in 1, we have 1 minus 1 cubed over 3 minus, plugged in -1, we have -1 minus -1 cubed over 3. And if we evaluate this, we will see that the answer will be 4/3. Next, we evaluate the second integral. It had the same antiderivative, which is x minus x cubed over 3, but this time we evaluate x equals 1 and 2. Plug in 2 to x, we have 2 minus 2 cubed over 3 minus. Plug in 1, we have 1 minus 1 cubed over 3, and this will also be 4/3, but it is negative. And so the total area is area 1 plus area 2, but we take the absolute value. It is 4/3 plus the absolute value of negative 4/3, which is 4/3 plus 4/3, or 8/3, the exact answer.